Okay guys, today we're going to talk about similarity in right triangles. The similarity in right triangles utilizes geometric mean, which we will learn how to do. So the right triangle similarity theorem states that if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So in the diagram that's to the right of yours and kind of here down to the lower right of mine, if I looked at the similarity statement, it would say that I was comparing large to medium to small. So I'm comparing this outer triangle to the medium one and the small one that make it up. So in other words, triangle ABC is similar to triangle ADB is similar to triangle BDC. I have to go in the same order. So I went ABC. AB is up the long side, down the short, with the 90 degrees in the middle. So then I went to ADB. Here's the long side of that triangle and the short side. This is the long side of the smallest triangle and its short side. Okay, so first example says to identify the similar triangles in the diagram and then to sketch them so the corresponding sides and angles have the same orientation. So I sketched the three triangles. And then I looked at, compared large to medium to small. So the large triangle was triangle PQR. The medium-sized triangle, starting on the long side, was triangle PSQ. And then the small one, the 90 is located at S on it also. The long side starts at Q. The short side ends at R. So QSR. Okay, we can use some of the similarities to determine parts of the sides. So, to determine parts of the sides, if I'm looking here at number 2, I'm going to look at the medium-sized triangle compared to the big triangle. So on the medium-sized triangle, I have X as its bottom. On the large triangle, 9 as its bottom. That's equal to the hypotenuse on the medium-sized is 12 over the hypotenuse on the large size is 15. I can then cross multiply and get 15x equals 108. And then if I divide by 15, I am going to get a decimal. So 108 divided by 15, I get that x is 7.2. If I worked on problem 3, again, I'm going to work with the medium triangle and I'm going to work with the large one. So if I do short side over short side, so x over 11.2 equals hypotenuse of the large or the medium triangle 21 over hypotenuse of the large one 23.8. Then if I cross multiply, I have 23.8x equals 21 times 11.2 is 235.2. And then if I divide everything here by 23.8, I get a real ugly number repeating. I am going to round it to the nearest tenth, and it's 9.9. Same thing here on number 4. Short side to short side, hypotenuse to hypotenuse, so it'd be x over 7 equals 24 over 25. So I have actually 25x equals 7 times 24, 168. And then if I divide everything by that 25, I get that x equals 6.72, so I'm going to round it to 6.7. Okay, if I look here at the definition of the geometric mean, it says the geometric mean of two positive numbers, a and b, is the positive number x such that a over x equals x over b. Which, if we cross multiplied, we'd get that x squared was equal to a times b, and if I went ahead and solved for x, that x was equal to the square root of AB. So if I look at the next set of problems, on problem 5, it asked me to determine the geometric mean. I would highly suggest you use either x squared equals a times b, or x is the square root of AB. It will save you some work. So the two numbers they give me are a and b. Plug them in. So x equals the square root of 6 times 30. So x is the square root of 180. We know how to simplify these radicals. So I know that 36 times 5 is 180. So I'm going to break this down. 36 times 5. This should simplify to be 6 radical 5. If I look at problem 6, x is equal to the square root of 16 times 28. If I go ahead and multiply them, x is equal to the square root of 448. I know I can take out a 16, I can take out a 64, so 448 divided by 64 leaves me with 7. So I'm going to break this down to be the square root of 64 times 7, and the square root of 64 is 8 radical 7. Again, on 12 and 50, x would equal the square root of 12 times 50. Square root of 12 times 50 is the same as the square root of 600. If I take the square root of 600, I know I can divide out a 25. I think I can divide out 100, and it would be 100 times 6. Square root of 100 is 10 radical 6. We are going to use this geometric mean to find either missing altitudes or missing parts of triangles. So the geometric mean altitude theorem says that the length of the altitude is the geometric mean of the lengths of the two segments. So in other words, that BD squared, which is the altitude squared, is equal to the lengths of the two segments that make up the hypotenuse, AD times DC. So if we think about this, it's altitude squared equals part times part, or part 1 times part 2. Okay, so let's look at some examples of this. Example 8, the altitude squared, so x squared equals part 1 times part 2, so 8 times 12. So I've actually got that x equals the square root of 96 and I know that 96, I can take out a 4, I can't take out a 9, but I can take out a 16, and this is actually 16 times 6, which breaks down to be 4 radical 6. On number 9, I know the whole of the hypotenuse and I know one part, so I'm going to go ahead and subtract 37 minus 5 and get that this part's 32. So then my altitude squared, x squared, is going to equal part 1 times part 2, or 5 times 32. So I've got that x squared is actually going to equal 160. Take the square root of both sides. So I've got that x is the square root of 160. I know I can divide out a 16, so let's make it the square root of 16 times 10, which is going to be 4 radical 10. Example 10. This time they give me the altitude, but I'm missing either part 1 or part 2. I go ahead and label them. So I've got 18 squared equals x times 15. So 18 squared is 324 equals 15x, and then I'll divide the whole thing by 15, and I get that x is equal to 21.6, excuse me. Over here on number 11, if the whole length is x and I've got 30 taken out of it, then this part would be x minus 30. So now if I square the altitude, it'd be 21 squared equals 30 times x minus 30. And I can solve this. I get 441 equals 30x minus 900. I'm going to add 900 to both sides. So I've got 1,341 equals 30x. Divide everything by that 30. And I should get 43.25 and some ugly numbers. So let's call it x equals 43.3. Okay. The geometry mean leg theorem says that the length of the leg of the triangle is the geometric mean of the lengths of the entire hypotenuse and the segment of the hypotenuse that's adjacent to the leg. In other words, if I broke it down by this triangle, I could say that AB squared, that side squared, equals AD times AC, so part times whole, or BC squared is equal to CD times AC. I break it down a little more into layman's terms, and I said that the leg squared is equal to the part times the whole, the part that touches it times the whole length. So for example, on problem 12, the leg squared, so x squared, is equal to the part that touches it, 24, times the whole length, which the whole length would be 24 plus 2, or 26. So it might help if we went ahead and labeled this that the whole thing was 26. So I've got x squared is equal to 24 times 26 is 624. I'm going to take the square root of both sides then. I get that x is equal to 624. It divides by 4 evenly. It divides by 16 evenly. And it leaves 16 times 39. So then I can break this down to 4 radical 39. If I break down that 39, the only things that multiply to make 39 other than 1 in itself is 3 and 13, and so there's no perfect square that can come out of it. On number 13, my leg is here. I don't have the piece of the hypotenuse that touches it, but I do have the whole length and the other one. So I can take 12 minus 7 and get that this piece that touches it is 5. So now if I do leg squared, x squared equals the part that touches it 5 times the whole length 12, or x squared is equal to 60. Square root both sides. So I have x equals 60. If I break it down, I can break it down to 4 times 15. That's the biggest perfect square that will come out of it. So my final answer is actually 2 radical 15. If I keep moving, example 14. This one makes it a little bit bigger. I'm going to start with finding x using that leg theorem. So the leg squared, 27 squared, equals the part that touches the leg, 24, times the entire length, x. So whenever I take 27 and I square it, I get 729 equals 24x. If I divide everything by 24, I get 30.375. So now if I know what that whole length is, to find y, I can use the altitude theorem. 30.375, subtract 24 leaves me 6.375 for that part. So to find y, the altitude squared, y squared, equals the product of the two parts. So 6.375 times 24. So 6.375 times 24 is 153. So I've got y squared is 153. If I take the square root of both sides, I can't divide 153 by 4. I can divide it by 9, and it's 9 times 17. So y is actually going to be 3 radical 17. Now, if I want to find z, I can use the back to the leg theorem, and that the leg squared, z squared, is equal to the part that touches it, 6.375, times the entire length, 30.375. So 6.375 times 30.375 is 193.64. So I've got z squared is 193.64. Take the square root of both sides. And I get 13.915, so z is going to be 13.9 whenever I round it to the nearest tenth. You can do the same on number 15. I'll start with finding x first. For x, I'm going to use the altitude theorem. So the altitude squared, 8 squared, is equal to the product of the parts, so 20 times x. So I've got 64 equals 20 times x. If I take 64 and I divide it by 20, I should get 3.2 is x. So now I know that part. I can then add these two pieces together and get that whole length is 23.2. To find y, I can use the leg theorem, which is y squared equals the part that touches it, 20 times the whole length, 23.2. So I've actually got y squared equals 20 times 23.2 is 464. If I take the square root of both sides, I'm going to look for the biggest perfect square that can come out of 464. So I start out, I try dividing it by 4. That's 4 times 116. I try dividing it by 9, it doesn't work. Try dividing it by 16, that's 29, and 29 is a prime number, so that's as far as I can go. So I've got 16 times 29, which makes y be 4 radical 29. To find z, leg squared, z squared, is equal to the part that touches it, 3.2, times the whole thing, 23.2. So I've actually got z squared equals 3.2 times 23.2 is 74.24. Take the square root of both sides. And I get that z is 8.616 and a bunch of other ugly numbers rounded to the nearest tenth, 8.6. Next example.